This is the 5.4 to 5.5 review, and in this case we finally get a calculator. So on this exam, both of the free responses are going to be calculator allowed, and they'll both be on that same section. So all the multiple choices are going to be without a calculator this time. Okay, so if we look at this, we have a car traveling on a straight road, and I've given you an initial velocity. So I gave you a point on the velocity curve. We're on a closed interval, and I've given you a picture of the acceleration, which is the derivative of the velocity. So because I have a point on the velocity curve and I have the derivative of the velocity, chances are pretty good I'm going to have to use that velocity function, and I'm going to have to write it. So I'm going to do that right now before I even do anything else. I know the velocity at any time is going to be the velocity I start with, which is 55, plus the accumulation from when I have it up to t on that acceleration. So looking at the picture, I'm going to have to accumulate under this graph and below and above all this stuff. So we're going to be able to figure this out for any point because we're going to have rectangles and squares and trapezoids and triangles. So chances are good we're going to have to be accumulating and finding velocities. So if we look at part A, it says, is the velocity of the car increasing? Why or why not? So a velocity is just like any other function. In order for it to increase, we have to have v prime be positive. So we can write down v prime, or v increases, when v prime, which is the same as the acceleration, is greater than 0. So really we just need to go see what that acceleration is at 2. Notice since we have a picture of the acceleration, we're looking for the output at 2. So I go to 2 up to 15. That's greater than 0. So yes, v is increasing. If we look at part B now, it says, at what time in the closed interval is the velocity of the car going to be 55 seconds, and why? Okay, so we know that if we plug in a 0, we will accumulate nothing and we'll get 55. So this question is really asking, when is that accumulation going to give us nothing? So the only way we'll get an accumulation of nothing is if we have as much positive accumulation as we do negative accumulation. So when does that happen? Well, this one looks like it's got a base of 6 and a height of 15 with a width of 2. So we've got this trapezoid. We want to create the same size trapezoid over here. We can see that we're going down 15, so that height's going to be good. We need our bases to be the same. So we need a base of 2, which will happen at 12. And we check the other base, and that's going to be 6. So we can see that if we stop at 12, we'll have as much positive accumulation as we do negative accumulation. So at what time? We can say v of 12 equals 55 because the accumulation from 0 to 12 of that acceleration curve is 0. Okay, if we look at part C now, it says we want to find the car's absolute maximum velocity and figure out when it happens on the closed interval. So I'm going to pick out a different piece of paper here so that we can look at our graph at the same time that we're doing this. So I'm going to write on the yellow paper. We would say that v has its max. Was it max we were looking for, or min? Let me check here just a sec. It is the max. Okay, so v has its absolute max either at an endpoint or when v prime, which is the same as a, equals 0 or undefined. So we are listing all our critical points and our endpoints. Now what I'm going to do is, rather than narrowing our hunt just to when v prime changes from positive to negative, I know coming up that I'm going to have a question about the minimum. So I'm just going to do them all at the same time, and I'm going to test them. We know this is our velocity function, so our options are v of 0, Our next critical point is going to be v of 6 because the acceleration is 0. We have another option at 16, and we have a final option at 18. So I will scoot in just a second so we can see the 18. We already know v of 0 is 55 feet per second because that was given to us. V of 6 is going to be 55 plus that accumulation from 0 to 6 on the acceleration curve. So that means I need to accumulate this region right here. So that's going to be a 1/2 times a 6 plus a 2 times a 15. So I get a 1/2 of an 8. That's a 4 times a 15 gives me 60 plus 55. So I end up with 115 feet per second. If I look at 16, now I'm going to accumulate from 0 to 16. So that's going to be the 55 I start with, plus this accumulation, which was 60, minus the accumulation to 12, which is 60. And then I'm going to have some more of this, whose area is a 1/2 times the height is 15, and the bases are, looks like 4, and 12 to 14 gives me 2. So I got 1/2 of 6 is 3 times 15 is 45, so that 55 minus 45 gives me 10 feet per second. And then I'll scoot up just a little bit here, see if we can squeeze in that 18. That one will be 55 plus the accumulation from 0 to 18, which will be the 55 plus the 60 minus the 60 minus the 45 that we accumulated here. And we're going to get a triangle, which is above the x-axis, so we'll add 1/2 the base, which is 2, and the height, which is 15, so we end up with 25 feet per second. So if we look at this list now, these are all of our extreme values. We have endpoints and we have all our critical points, so it's an exhaustive list of all of our maxes and mins. We can see that the biggest one happens right here at 6. So we have V has absolute max of 115 feet per second when t equals 6 seconds. Then the final question, part D, says at what times in the interval, if any, is the car's velocity equal to 0? And then we have to justify our answer. Well, if we go back and look at our list here, here's all our maxes and all our mins, and notice that the smallest number in that list is the 10. So this is our absolute min, and it's a 10. So 0 would be smaller than the absolute min, so that means we're never going to hit it. So for part D, what we're going to write, or excuse me, yes, for part D, we'd say never, since V has an absolute min of 10 feet per second at t equals 16. And we're done.